Hello everyone. In previous sessions, we completed the chapter permutations and combinations. In this session, let us start the new chapter probability. Will it happen or not? What are the chances that a particular event will occur? How certain are you it will occur? We talk in terms of probability all the time. This course covers many basic concepts needed for probability. Suppose a coin tossed. What is the probability of getting head and getting tail? Suppose a die rolled. What is the probability of getting 1 or 2 or 3 or 4 or 5 or 6? Like this. Now, let us see the contents in this chapter. Random experiment, elementary event, sample space, mutually exclusive events, exhaustive events, and equally likely events. Random experiment on trial. A random experiment is an experiment that can be repeated any number of times under identical conditions. Those are all possible outcomes. All possible outcomes are known in advance. Known in advance. Actual outcome in a particular case is not known in advance. Not known in advance. So, random experiment is an experiment that can be repeated any number of times under identical conditions. All possible outcomes are known in advance. Actual outcome in a particular case is not known in advance. Take example of random experiment. Toss a coin. Toss a coin is a random experiment. And roll a die. Roll a die is a random experiment. So, toss a coin is an experiment. Roll a die is an experiment. Toss 2 coins, roll 2 dice. All these are becomes to random experiments. Elementary event or simple event. An outcome of a random experiment is called an elementary event or simple event. An outcome of random experiment is called elementary event or simple event. Suppose, see the example. Toss a coin. This is one example. Toss a coin. If we toss a coin, we will get either it is head or tail. So, these are called elementary events or simple events. So, when the experiment toss a coin, the elementary events are getting head denoted by capital H and getting tail. It is denoted by capital T. And take one more example. Roll a die. In a random experiment, roll a die. If we roll a die, we will get 1, 2, 3, 4, 5, 6. Like this, outcomes will come. Now, roll a die. The elementary events are getting 1, getting 2, getting 3, getting 4, getting 5 and getting 6. So, when toss a coin, random experiment toss a coin, the elementary events are getting head and getting tail. When roll a die, the elementary events are getting 1, getting 2, getting 3, getting 4, getting 5 and getting 6. So, these are outcomes and also these are called elementary event or simple event. Event. A combination of elementary events is called an event. Combination of elementary events is called an event. Next one is sample space. Sample space is all possible outcomes. All possible outcomes of a random experiment. All possible outcomes of a random experiment is called sample space. Sample space. And it is denoted by capital S. Sample space is denoted by capital S. All possible outcomes of random experiment is called sample space. It is denoted by capital S. See the examples. In a random experiment, toss a coin. Toss a coin. Sample space S is H comma T. When we toss a coin, the elementary events are getting head and getting tail. These are called elementary events or outcomes. All possible outcomes of random experiment is called sample space. So toss a coin, all outcomes are H and T, getting head and getting tail. Therefore, sample space of toss a coin S equal to H comma T. And in a random experiment, roll a die. In a random experiment, roll a die. Sample space S equal to 1, 2, 3, 4, 5, 6. When we roll a die, the outcomes are 1, 2, 3, 4, 5, 6. Therefore, sample space S equal to 1, 2, 3, 4, 5, 6. And take one more experiment. Toss 2 coins. Toss 2 coins. In a random experiment, toss 2 coins. Then sample space S equal to head head, head tail, tail head, tail tail. So these are the outcomes of toss 2 coins. Then toss 2 coins, sample space S equal to HH, HT, TH, TT. And roll 2 dice. Roll 2 dice. Then sample space S equal to, if we roll a die, sample space 1, 2, 3, 4, 5, 6. Roll 2 dice, then sample space is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2 comma 4, 2 comma 5, 2 comma 6, 3 comma 1, 3 comma 2, 3 comma 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6 and 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So roll 2 dice, then sample space S is this one. If toss a coin, sample space S is H comma T. Toss 2 coins, sample space S is HH, HT, TH, TT. This implies we can write toss a coin, sample space S is H comma T. Then N of S, number of sample space points, that is 2 to the power 1. And here toss 2 coins, this implies N of S is 2 square. And roll a die S equal to 1, 2, 3, 4, 5, 6. Then N of S is 6 to the power 1. Roll 2 dice. Roll 2 dice. N of S is 6 square. N of S is 6 square. Like this. Toss a coin, N of S is 2 power 1. Toss 2 coins, N of S is 2 square. Toss 3 coins, N of S is 2 cube. Toss 4 coins, N of S is 2 to the power 4 and so on. Toss N coins, then what about N of S? 2 to the power N. Similarly, roll a die, N of S is 6 to the power 1. Roll 2 dice, N of S is 6 square. Roll 3 dice, N of S is 6 cube and so on. Roll N dice, N of S is, obviously it is 6 to the power N. Next definition, let S be the sample space of a random experiment. The event pi is called impossible event and the event S is called certain event. The event pi is called impossible event and the event S is called certain event. Come to the next definition, mutually exclusive events. Mutually exclusive events. The events E1, E1, E2, E3 and so on En are said to be mutually exclusive events. Mutually exclusive events. If EI intersection EJ equal to pi for I is not is equal to J. I not equal to J. The events E1, E2 and so on En are said to be mutually exclusive events if EI intersection EJ equal to pi for I not equal to J. In other words, 2 or more events are mutually exclusive if one of the events prevents as the occurrence of any of the remaining events. That is also called mutually exclusive events. 2 or more events are said to be mutually exclusive events if one of the event prevents as the occurrence of the any of the remaining events. is called mutually exclusive events. Or the events E1, E2, E3 and so on En are said to be mutually exclusive events if Ei intersection Ej equal to pi for I not equal to j. Take one example. In a random experiment, roll a die. In a random experiment, roll a die. When roll a die, the outcomes are, or the elementary events are 1, 2, 3, 4, 5, 6. Elementary events or outcomes. Those are 1, 2, 3, 4, 5, 6. Now, what is event? Event means a combination of elementary events is called an event. A combination of elementary events is called an event. So, let E1 be the occurrence of, that means E1 be the event that occurrence of an even number. An even number. That is, when roll a die, what are the even numbers? 2, 4, 6. 2, 4, 6. These are even numbers. And take one more event, occurrence of an odd number. Occurrence of an odd number. In a random experiment, roll a die. Odd numbers 1, 3, 5. Now, if we observe these two events, E1 be the event that occurrence of an even number 2, 4, 6. E2 be the event that occurrence of an odd number 1, 3, 5. Now, E1 intersection E2. What is E1 intersection E2? Is there any common here? 2, 4, 6, that is first event E1 and second event 1, 3, 5. So there is no common. Then E1 intersection E2 equal to pi. That means these two events E1 and E2 are called mutually exclusive events. So, two or more events E1, E2 and so on En are mutually exclusive events if Ei intersection Ej equal to pi for I not equal to j. That means take a random experiment, roll a die. E1 be the event that occurrence of an even number 2, 4, 6. E2 be the event that occurrence of an odd number 1, 3, 5. Therefore, these two intersection, E1 intersection E2 equal to pi, that is, E1 and E2 both the events are mutually exclusive events. Next definition, exhaustive events. The events E1, E2, E3 and so on En are said to be exhaustive events. Exhaustive events. If E1 union E2 union E3 and so on union En equal to yes. The events E1, E2, E3 and so on En are said to be exhaustive events if E1 union E2 union E3 and so on union En equal to yes, are also all possible events of a random experiment. All possible events of a random experiment is known as random experiment is known as exhaustive events. Exhaustive events. So, all possible events of a random experiment is exhaustive events. It is nothing but sample space S. So, the events E1, E2 and so on En are said to be exhaustive events if E1 union, E2 union, E3 and so on union En equal to S. All possible events of random experiment is also known as exhaustive events, that is nothing but sample space S. Now see the example. When two coins tossed, this is a random experiment. Two coins tossed. The events E1 be the event that HH HT and E2 be the event that TH TT. So these two events are exhaustive events. Why? E1 union E2. When two coins tossed, already you know sample space S. That is S equal to HH HT TH TT. Now here E1 be the event that getting HH HT and E2 be the event that getting TH TT. So this implies E1 union E2 equal to S. That means these two events are exhaustive events of a random experiment, two coins tossed. And see one more example. When roll a die, E1 be the event that getting even numbers. E1 be the event that getting even numbers. And E2 be the event that getting odd numbers. Then here E1 union E2, that is yes. 1, 2, 3, 4, 5, 6. E1 union E2. So that equal to yes. That means these two events E1 and E2 are exhaustive events. Exhaustive events. Next definition is equally likely events. Two or more events. Two or more events are said to be equally likely events. Equally likely events if they have equal chance of happening. Equal chance of happening. See the example of this. Suppose in a random experiment, toss a coin. Getting head and getting tail are equally likely events. These are equally likely events. And take one more example. Roll a die. Roll a die. In this experiment, the events E1 be the event that, see one more example. In a random experiment, roll a die. In this experiment, let E1 be the event that getting 1, 3, 5 and E2 be the event that getting 2, 4, 6. So these two events are so equally likely events. Equally likely events. So, two or more events are said to be equally likely if they have equal chance of happening. That is called equally likely events. In this example, roll a die also. E1 be the event that getting 1 comma 2, E2 be the event that getting 3 comma 4, and E3 be the event that getting 5 comma 6. These events also equally likely events.